Hello, everyone. Welcome to week 5's workshop for Godot's GameStart series. Unfortunately, this is not the actual session because in the actual session, I forgot to screen share. So it only recorded my Zoom tab instead of my screen. Yeah, so this is a separate video. And so in this video, I will be a bit faster in all the demos. Yeah, so if you need more time to complete the tasks, just pause the video, right? Okay, so before this week's content, I will do a live demo on some of the leftover tasks last week. So the first task is to add a label for the number of remaining arrows. Right, let's go to Godot. Right, so in order to add a label somewhere here, we just add a child node under the UI, which should be a label node. And we can call it arrow label. Right. We can move the label here and maybe put in some text to check its position. Okay, maybe we want to do something like times one, right? Times one, right? And right, if we want to have the same font, we should go to the theme and then drag the font into the theme. Oh no. Okay, first we need to add a new theme first. Click on the new theme and drag the font into the theme. And change the font size to 64. Right. Okay, maybe we don't need the space here. So just arrow times one. Okay, so the idea is just to modify the text property of this arrow label in our code. Whenever our arrow count changes, we should modify the text property. Okay, so where did we store the arrow count? It should be in the player script. Right, we call that, we have a max arrow count, and then we initialize the arrow count variable to be the max arrow count. And later, when the player shoots the arrow, we will minus the arrow count. And then when the arrow count timer is timed out, we will replenish the arrow count. So these are the places that we will need to modify the text. In order to modify the text, we first need to access the node as usual. So we will have a variable called health label, or not health label, it should be arrow label, right? And when the player node is ready, we will need to access the node. So arrow label equals $. Let's try to find the relative position of the arrow from the player. So in the player, we should go up one level to game, and then find UI, then find arrow label. So back in our player script, we should do /UI/arrow label. Right, now this variable will point to the arrow label node, and we can access the text property of arrow label. Okay, so in the two positions that we change the arrow count, right after changing the arrow count, we should set the text property of arrow label to be something, to be the arrow count, right? So we can do something like this, equals x %d, then %arrow count. Okay, so what's this? This is actually the format specifier in Godot. Okay, this X is the character X, but this %d is a format specifier for an integer. And it is going to be replaced by this arrow count integer in the actual string. So this string will look something like x1 or x0, depending on the arrow count. Okay. And we can copy paste this one. And after the arrow timer times out, we do the same thing. Okay. And that's one more thing we need to do, which is initializing the label text. So we can do arrow label.text equals, yes, we have this variable arrow count already. Yeah, so it's safe to do this. You can also do like max arrow count, which is the same effect. Okay, let's start our game. Right. So now you can see the arrow label is changing whenever the arrow count changes. All right, that's all for this demo. Maybe another thing is the color of the labels, because our background is somewhat white, right? We don't want our labels to be white. And there is a way to configure the color of these labels, which is, I think is in theme overrides, right? And there's a colors. So there is a font color you can apply to your theme. And it's default to be black, but it's not checked. So just check this font color. And we can do the same for the health label as well. Okay, now we can start our game and check that the labels have been changed to black. All right, that's our first demo, right? And the second demo is actually a continuation of last week's topic on audio stream player 2D, right? So recall that last week we talked about why we should store the audio stream player 2D in the game node, these two, instead of the player node or the orc or the arrow node, because that's to handle the case that the arrow node is queued free immediately after the sound is being played, right? But there is a problem with this approach, or there's something that is incomplete with this approach, is this audio stream player 2D will have the same initial position that we give them, and they are not being changed to the actual position that the sound is being played. To solve this one, we can just set the position of these audio stream player 2Ds when the sound is being played. Right. For example, in the arrow script, right before the enemy sound is being played, we can set the enemy hurt sound's position to be position of the arrow, right? Because at this point, the position of the arrow is where the arrow hits the enemy, which should be the position that the hurt sound is being played. Okay. And for the other sound, for the player hurt sound, it's similar in the player script. Right before the player hurt sound is being played, we should set player hurt sound position to be the player's position. All right, so yeah, try to understand this logic. So when this event happens, when the player is going to take damage, we will first move the audio stream player 2D to be the player's position, which should indeed be where the sound takes place, right? And then we play the position, play the player hurt sound, so that it is more real, so that it's we are closer to the position that the sound is taking place, and we can hear the sound in a louder volume. Let's try that. right? Okay. So if I shoot this orc when I'm very close to it, we actually hear a very loud sound. But if I shoot this in a far position, the sound should be slightly less loud. Okay, so yeah, that's the intended effect. And by the way, this is just to demonstrate how audio stream player 2D works. And in the actual game project, right, I think the more proper approach is to instantiate a new instance of your audio stream player 2D in the game. Recall that last time we preloaded the arrows. Yeah, we preloaded the arrow scene, and then we instantiate one when we need an arrow instance, right? We can do something similar. So we can preload the sound scene, and when the sound is taking place, we can instantiate and add to the game node. And there should be a signal in the AutoStream Player 2D, which is when the audio is finished. So right after it's finished, we can queue free itself. Right. So we don't have leftover audios in our game. Yeah, that's the proper approach. All right. So that's all for these two demos. And we can start on this week's topics. So yeah, let's just take an overview of all the topics over these 4 weeks. And this week we are going to cover some more advanced topics that allows you guys to make a bigger game. Okay, so the topics include camera and tile map. We will revisit the background, but we have a better background. We will also handle the logic of changing the levels, right? And I'll cover a bit more about how do you guys work in a group to commit to the same GitHub repo. And in the end, how do you export and publish a game? Because of the time constraint, this week we wouldn't have any hands-ons and challenges, right? I don't mean that they are not important. They are the most important in internalizing the skills, but it's just that this week we have too many topics. We cannot finish in time, right? But I believe in the upcoming week 5 game jam, you guys will have a lots of hands-ons and challenges, right? So yeah, you guys can just try to practice all the skills on the actual event itself. So let's look at the output of today's workshop. So yes, I have uploaded the game onto HIO, and we can change the levels, right? We can pause the entire game and resume. And you see, we have a bigger map now. It's kind of like a platformer already, right? And we have different tiles, different backgrounds. All right. Okay, so I hope you are excited. Let's move on to the first topic, which is the camera. Okay, so to add a camera to our game, there are many approaches, but if you want your camera to follow the player, right, then it is quite simple. You just add a camera 2D child to your player node. Okay, let's go to Godot and player scene. So we just add a child node and we search for camera 2D. All right. Okay, that's enough. That's sufficient for the camera to move the player, to follow the player already. Why? Because camera 2D is a child of player, it will always have the same position as the player when the player moves around. And then when the camera's position changes, we will have a changing view of the game. based on its position, which always follows the player, right? Yeah, that's very simple. But the real challenge comes in setting all the properties of the cameras. Okay, let's look at the properties. So the first one is an offset, right? This just means an offset of the camera 2D from the player's position. So if you don't want your player to stay at the center of the camera, you just change this offset. Okay, so let's say I want the player to be somewhere in the bottom left of the camera, right? Then I should move the camera to the right and up, right? So that the player is bottom left. So I should assign a positive X offset, maybe 100. And then to move it up is a negative Y offset of 100. And let's see. You can see that the player is off center now by this offset. Okay. And the zoom, as the name suggests, is how the camera is zoomed in, right? So let's say we don't want it to be so zoomed in. We want to zoom out a bit so we have a better view. Then we set it to be a value smaller than 1. Then it's zoomed out a little bit. All right. Okay, next we have these 3 important properties. So we have the smoothing property, limit property, and drag property, which are very powerful in handling the camera. Okay, I must say, when I first tried to work with camera, I didn't know about this, and then I spent a lot of time coding the logic just to achieve the same effects. But Godot have all the properties for you that it does the calculation for you already. So yeah, just use these properties. They are really powerful. The first one is the limit. So this basically means how far the camera can go, right? If the camera moves beyond this limit, then it should stop there. It shouldn't go beyond this limit. Okay, so let's say we don't want the camera to go too low in the case that the player drops from the platform, right? Then we can set the bottom limit to be, let's say, 2000 pixels. Maybe the top one can be minus 2000. Right, let's try. So let's say I make the player jump off this. Then, okay, maybe it's hard to see here, but yeah, if you look closely, the camera stops moving after a certain limit, right? It prevents the camera from going beyond this very low value of your Y value. Okay, right? That's a limit. And for smoothing, right, it's just a 1 button click, and it just means that the camera will start moving gradually and will stop moving gradually, which is provides a bit better experience for the player, right? And we also have this drag property, right, which is very useful. So let's just try it. Let's just try to enable the horizontal drag property, and we leave all these remaining properties as they are, right? Let's see what happens. See, when I move a little bit, the camera is not moving at all, right? So after I move, then yeah, after I move past some margin, then the camera moves. So this allows a small box of area that the camera doesn't move, right? Which is also a better experience, right? It only moves when the player tries to navigate some area, right? Which is very useful, yeah, for players like me. In fact, I have motion sickness, so if the camera always moves with the player, then I feel a bit dizzy. But this way, it's much better for me. Okay. Yeah, so this one, drag property. All right, so yeah, that's all the properties, the important properties that you need to set for your camera. Okay, so when we talk about camera, right? Maybe okay, before the background, we want to address the issue of why the UI is not moving with the camera, right? Now the UI and the other objects are on the same layer. So when the camera moves, you can see the UI is moving, right? Which is not what we want. To solve this one, we just need to change the type of the UI node to be canvas layer. Canvas layer. Okay, so what it does is it separates the UI from the other nodes in your game. It will be on a different layer from all these games, that the canvas layer's position doesn't change when, it is like fixed to the viewport. So its relative position to the viewport doesn't change when other things move, right? So now we have a UI that is fixed to the viewport. Okay, right, so canvas layer for the UI. All right, so for the background, last time we just had these sprites as a background. And today I will teach you guys a trick that makes the game more real by applying an effect of depth to the background. So you see when the camera moves, right? Currently the background is moving at the same speed as the front layers, right? Which doesn't feel real because the background should be deeper than other stuff. That's why it should move slower than the other stuff. Right. To achieve this, there is one child node called parallax layer, parallax background and parallax layer. Okay, so let's create a parallax background node and we can shift it to the top of the list, which is the background. And we need to add a parallax layer child to this parallax background. So there are a few properties that we can define here to achieve the effect that we want. Okay. Now let's just remove these two sprites because it has some undesirable properties that we set last time, like the scales and the positions. We'll just remove these two. And then in the parallax layer, we add two child nodes or two sprites. Maybe you can rename them as background, background cloud. So similarly, we just drag our two background images onto the two sprites. Okay, so let's give them some scales for them to cover our game. So let's go to the two sprite nodes under transform. We set the scale to 6, maybe. Right. 6. And we don't check, we uncheck this center so that it's more aligned to our viewport, which is useful later. Right. So uncheck these two center. Right. Okay, so in parallax layer, under the motion properties, we can set the motion scale. The motion scale is how fast it moves compared to other objects, right? So if you want the parallax layer to move slower than the other objects, we set a lower scale. maybe 0.2. Now let's check. Right? So you can see that the game feels more real because there is an illusion of depth in our game, that the background is deeper than the front layers, right? All right. And yeah, there is another property called mirroring. Okay, this one is to support an infinite scroll of your background. So when the camera moves past these positions, this amount of pixels, then it's going to mirror the background by creating a copy of the background and extend it further, so that the background will be infinite, right? So the length of mirroring that we set here should be the actual dimension of the backgrounds after the scaling, right? So let's check the dimensions of the background. Okay, so it's 496 times 272, and we need to multiply them by the scale factor, which is 6. So let's go to parallax layer. Under mirroring, we type in 496 times 6. Then it's going to calculate for us. For the y value is 272 times 6. All right. Okay, so it gives you a preview that it is being copied correctly. So if this value is wrong, then it will give you this kind of preview, which you know that it's wrong. So send it back to 2976, and it shows that it will mirror, and then they're going to match perfectly. So yeah, let's try the effect. Right, now we have a seemingly infinite background. Okay, right. Okay, so that's all for the camera and background. And now we have configured our game to be able to extend further, right? We have an infinite background, we have a camera that follows the player, and we can create bigger games now by using this very powerful tool called tile map. So what's a tile map and what's a tile set? Tile map is basically a map for your game, which is made up of the tiles, right? The tiles come from your tile set, and they are the building blocks of your tile map, right? Okay, so let's go to Godot and create a new scene. We choose tile map scene. Maybe you can rename this to map. Okay, let's save this scene first. Okay, so click on the map, and then there's a tile set property here. We can create a new tile set, and then click on the new tile set that we created. Right. So we can see there are 2 more tabs at the bottom bar now. One is tile set, one is tile map. This is where we configure the tiles and then add to our map. Okay, so let's go to the tile set tab, and then we will drag a image into the tile set, and in order to create the tiles. So the image we're gonna use is in one of the previous folders, right? If you deleted the folder from last workshop, just go to the first link I sent last week for all the assets. It should be called character and background, and then there's a tiles folder. So download this folder, and under tiles assets, there is an assets.png, which contains all the tiles for this for this asset pack. All right. So we just drag the assets into the file system. Let's say we rename it to tiles.png. And we just drag the tiles image into this tile set, into this box. Okay, so there is a pop-up asking if we want Godot to automatically create all the tiles, right? So if we click yes, then it's going to create one tile in every grid, right? If you see here, there are very many grid cells, and then it's going to create one tile in each of the grids. And for today's workshop, we just click no, right? Because we want to try to create our own tiles, and we can actually create bigger tiles, can create a bigger rectangle than just one grid cell. Okay, so now we are in the tile set, and make sure you have selected the setup. So the setup is where you create the tiles. Let's first try to just create one tile in one grid cell, right? Maybe we can use this one, right? So you just need to click on this tile, and then it will light up. It means that this tile itself has been created. Now we can configure the properties of this particular tile. So to do that, we choose this select tool and click on this one, so that we go to all the properties of this tile itself. And okay, so today we're only going to cover one property, which is the most important property, that is the collision shape of this tile. Because this tile is going to be the platform for our game, right? Then its collision shape is important, yeah. So right now there isn't any place that we can configure the collision shape. That's because we haven't defined the physics layers of this tile set. So in the tile map, make sure this you have selected this tile set. Then there is a property called physics layers. This one is quite similar to the physics layers of your other Node 2D project or Node 2D objects, right? So they have the collision layer and the collision mask that you can configure. So because the tile map is a platform, we should choose a collision layer tree. You can still see that we have the platform label from last time, right? So select collision layer tree, and then collision mask just unselect. And after we have defined this physics layer, there will be this physics property for this tile, and we can access this physics layer 0, right? So in the future, maybe if you want to have different physics layers for one tile set, then you can just add physics layers here. Then you can configure them separately. You have physics layer 0, 1, 2, etc. But for today, we just need one physics layer, which is the platform layer. So under physics layer 0, we have this thing for us to specify the collision shape of this tile. So this we can expand the editor, right? And then control scroll to expand a bit more. So how do we do this? Okay, this one maybe is not being enabled for you. So, right, if it's like this, then go to this and then choose this grid snap. Maybe can set it to some large value like 32. So this will have a grid for our reference, and it's easier for us to make it horizontal and vertical, which is very important in our game, right? Because sometimes we have to detect if the player is on the ground, if the player is on the wall, then it's essential that our tiles are perfectly horizontal and vertical. In fact, let's say you have a surface that is not horizontal, right? Then you can imagine the tile set is going to look something like this, and then go up and like this, go up like this. And then the player is going to be trapped in this zigzag gap here, right? Which is not ideal. So yeah, in short, just make sure that they are horizontal and vertical, right? So to create a collision shape, we use this one, this add button here, right? Then we can add points in this image. We can add a few points here. And then remember to connect back to the first point. Then you'll see this thing turn red, and then this blue shape is the collision shape of this tile. Okay, so this is the add point. This one is for you to adjust, choose the points and adjust them, right? So in case you didn't click properly, okay, then you can adjust them later. And this one is the delete points, right? And delete the points. So let's say I'm very careless. I didn't make sure that it's horizontal. Right? Then after creating this, I can just select this one and pull it up so that it's the desired shape that I want. Okay, so now we have created this tile for our game. So after creating this tile, we can go to the tile map. You can see that the tile map shows you the tiles that you have created from this tile sheet. Right, this one is light up and it can be chosen. So let's choose this tile, and okay, make sure that you are in the paint mode in the tile map, right? Then when you hover your mouse over the editor, you can see that it shows the position of this tile. That means you can draw the tiles on the tile map. Okay, so you can left click to add a tile to the game, right? You can just long hold left click and then draw the tiles consecutively, right? All right. And to delete a tile, you need to right click at the position where you inserted the tile. So let's say I want to remove all these tiles. To right click, right, or I can just long hold right click and it will be like an eraser. Okay, right, and yeah, you can explore all the other tools that we have here, like you can create a straight line, right? You can have a rectangle of your tiles. Right, you can there's even a random tile option. If you have selected multiple tiles, then it's going to create randomly, which is very powerful, right? Okay, so let's say you want to edit the tiles in batch, edit them in a larger group, right? So you can just go to the selection tool and then drag over an area to select multiple tiles. Then you can move them as a group, or you can remove them. Just press delete and remove them altogether. Okay, so this is the process of creating tiles and adding them to the tile map. Okay, so let's go back to our tile set and create some more interesting tiles that we want in our game. So, okay, maybe the first tile I want is the ground for our game, right? So this looks like a ground, and I will choose this as I will create a tile here. So, okay, I want more than one tile, and I want a bigger rectangle. So see here, hold shift to create bigger tiles. So let's long hold shift, and then while you press shift, drag over these tiles. So it's going to be different from if you never long hold shift, right? You see, there's no grid inside this big tile, which means that this is one big entire tile, but not 6 separate tiles, right? Let's just clear these tiles. So now we have created a bigger 2x3 tile. So we can select this tile, right? And here, similarly, we can configure the collision shape for this bigger tile. Right, let's just add the point here. At the 4 corners of the tile. Right, now we have added the collision shape for this big tile. And in our tile map, we can use this tile in our game, right? Okay. So maybe let's just draw the tiles, right? Okay, let's add a ground to our game. Okay, just to mention that it may be not ideal if you keep dragging the tile, because what it does that it creates a tile every one cell, right? So if you drag, then there will be one tile in every cell, right? Which adds some performance overhead to our game, right? Because there are more tiles, so our game is less performant. And right, the proper way is something like this, like you don't repeat adding the tiles in the unnecessary positions, right? So there are less tiles, and then our game will be better. But in order to save time, you can just do this. So up to you. Okay, so that's the ground. And then maybe we want some walls in our game, right? Then for this purpose, we can use the rotation tool here. So if we rotate the tile to the right, then it's going to look like the left wall. Then we can just add this. We can add actually, let me just use the line tool here. And we can add the wall on the left. Okay, so for the right wall, similarly, we rotate twice so that it's facing the left. Let's use a line tool to create the right wall. Okay, so this is our battlefield in our game. Let's try to add some platforms to our game as well, so that our game will be a platformer, right? Let's go back to our tile set, and in setup, long hold shift to get this tile, which looks kind of like a platform, a floating platform. By the way, you guys can feel free to choose any tile you want, right? Just unleash your creativity and create a map in your mind, right? Okay, so we have, for me, maybe this looks like a platform. So I will set up this tile as a platform. Right, let me add the 4 points here. Okay. And because it's not horizontal, I should drag this lower to make sure that it's a perfect rectangle. All right. And in our tile map, we just add some platforms. All right. Yeah, that should be enough. Okay. So remember that in the demo, there was a wall a background wall somewhere here, right? That doesn't collide with the player. So it's actually very simple. We just create a tile that doesn't have a collision shape, right? So it shouldn't collide with anything, right? So the one I used is this wall here. Let me just create, oh no, setup and shift to create this tile. And that's it. We are done because we don't need to add a collision shape to this tile. Then we can just paint this tile in our game. Actually, I should use the rectangle tool here. Okay. All right. So yes, this is the map for our game, right? Yeah, it doesn't look very cool because we don't have time to design the map. But in your game projects, feel free to design bigger maps, right? Very long maps that the player can play for a very long time. Can add some creativity in your map as well. Just design all the patterns in your game by combinations of these tiles. All right. Okay, now let's go back to our game and we can add the map to our game now. So we just go to the game node and then instantiate child scene. So we choose the map scene to add to our game. And this will be the map, the platform in our game. And we can scale it. Or you can, this is scale. We can scale it to match the size of our current platform, right? Okay, this should be okay, right? So we can delete all the previous platforms that we had. Okay, just press delete to remove them from our game. And we'll need to adjust the starting positions of the characters, right? The players, the skeletons, and the orcs, etc. Right? Let's just put them at some random places. Okay, here's the thing, right? You see that the orc is behind the platform, right? So we need to make sure that the platform is behind everything else, right? So we make sure that the map is above all the players. It shouldn't be is above all the players. So the higher in the list, the more back it is. So now this orc should be in front of the map. Okay, let's start our game. Right. This is the new map of our game. Right. And maybe previously, our player is not strong enough to jump above all these platforms, right? We need to buff our players a bit. So we should go to the script, the player script, and increase the jump speed of the player, maybe also the speed of the player. Right? So the jump velocity should be something more negative, maybe 600. And then the speed can be like 300. Right? So now the player can jump in between all these platforms. Right? Maybe the values should be different on your end because of different maps. Just do the game balancing yourself. Make sure the game can be played through. Okay, so that's it for the tile maps. All right, let's check. Yeah, that's the entire procedure of creating the map for your game, right? It's very useful when you have a bigger game and you need to have many repeated tiles in your game. And then it makes the process very simple, right? You just create the tiles and then you do painting. It's like your Microsoft Paint that you you can use all the tools to simplify the repeated process of adding tiles. Okay, right. Okay, that's all for tile maps. Let me just take a sip of water. All right, let's move on. Okay, the next topic, we'll add some buttons to our game that have powerful effects. The first effect is to pause the entire game. Okay, I'll show you how to pause the entire game. It's actually quite simple. So before that, let's just create a UI button here. Under the UI, we need to have a button. Add a child node that is a button. Okay, we can add the text to the button. Let's just call it pause. Right? And then we drag the button somewhere on the right of the window. Okay, right. So this button is intended to pause the game when it's being clicked. Right? And recall that last time when we talked about signals, right? We mentioned a signal in the button that is that detects if when the button is being pressed, which is this pressed signal, right? Currently, we don't have any script in the UI. Maybe we want to handle all the UI events in the UI node itself. So we can attach a script to the UI first. Okay, and then we handle the logic inside the UI node, right? In the button, double press the pressed signal, and then connect it to the UI node. So there will be a new function called onButtonPressed, which is triggered when the player clicks on the button. Right? Okay, so how do we pause our game? That is actually a very convenient function, not a function, but a property of the game tree. Right? The property is getTree dot pause. Okay, recall that getTree will give you the entire scene tree of your game, okay, which I'll explain later, right? Then this tree has a property that is paused. So if this Boolean property is set to true, then the entire game is paused. So all the processes of the game will stop. All these processes and physics processes will just discontinue when it is true. Okay, so we want to pause the game here, right? So getTree.paused equals true. Then it's going to pause the game. But maybe we also want to resume the game when the player clicks on the button twice, right? So we should toggle the paused property instead of setting it to true. So this should be getTree.paused equals getTree equals not getTree.paused. So it flips the Boolean value from true to false, from false to true, right? Let's try this first. Okay, when we press the pause button, you can see the entire game is being paused, right? The BGM is paused, all the characters are paused, right? And we should expect that when we press it again, it should resume, but it's not. That's because this button is also a child of the game, right? If we pause the game, this button is also being paused. Then it's no longer going to detect user input because there's no process in the button, right? It doesn't process the user input anymore. So yeah, this approach is incomplete, right? And in order for the button to always stay alive, even when the game is being paused, we need to separate the button from the process of the game, right? There is actually a property here. So if you go to button and the inspector tab, okay, make sure it's button. In the inspector tab, there under the node, there is a process tab, right? Which specifies the process mode of your current node, whether it should inherit the process mode from its parent, or it should be some constant value that doesn't change. So if we set this process mode to be always, right? So this means that the button's process is always on. It's always not paused. It's always alive, even when the parent's process is being paused. Right. So let's change this and try. Now we have paused again, and if we press again, then it's going to restart. It's going to resume the game. Okay, there is something else that I'll show you later. So I'll just move here first, and I can pause it, and I can unpause it. Okay, yeah. All right. There's something that I forgot to handle just now, which is when the arrow hits the platform, it's going to return an error. So it says there's this get collision layer value function is non-existent in tile map, right? Solve the game first. Okay, why is this the case? So remember last time when we handled the arrow hit on other bodies, when the arrow hit the enemy, we checked if the body is an enemy by checking the groups of the body. But we still, for the platform, we still check by its collision layer value. But in this case, when the arrow enters the tile map itself doesn't have a collision layer. The collision layer is binded to the tile set inside the tile map, but not the tile map itself. Right, so that's why it's complaining that the tile map doesn't have this function, and we need to handle it separately. So maybe we can also define a group for the platforms. So yeah, it's easier for us to check whether the arrow is colliding with the platform instead of checking the collision layer value, etc. So let's go to the tile map. We want to make sure that this tile map is in a group called platform, right? Recall how do we set a group? We go to node and then groups. And we can manage the groups. We type in platform, add the group, choose this map, and remember to click on this add button, right? And check that inside the groups of map, there is one group called platform. Okay, so now here we can change to else if platform in body.getGroups. Okay, so this returns a list of groups that the body contains. So if the body is a map, it's going to return a list that contains the string platform, and then it's going to check that the body is indeed a platform. Then it will stop the arrow, etc. Okay, let's try it. Okay, now there's no more error, and the platform works just as well as our previous platforms. Okay, yeah, So yeah, that's to handle the error that we see just now. Let's go back to the UI and this one, right? Okay, so actually this one is done. Maybe we want want to enhance the UI a little bit. So maybe when the game is being paused, we should set the button's text to be resumed. So we can do something like if it's currently paused, if get3 dot paused, then this button's text should be paused. No, should be resumed, right? And then else, the button's text should be paused. Okay, so it basically changes the text of the button responsively when you're currently pausing the game or not. Let's check it out. Right? Okay. So some of you with sharp eyes may have noticed that when you click on the pause, then yes, the arrow is actually being shoot here. Right? So actually, when we click on the button, our mouse input event is still being caught by the arrow, right? Then by the player script, and then it's going to shoot the arrow to our mouse. Okay, let's solve this one. Let's go to the player script. Right. Okay, so the reason that this happens is because this input is how do you say that? It doesn't care if you are pressing the button or not. Maybe I should explain in the button first. So in the button, if you go to inspector and there is a mouse property, and then it actually have a stop filter for the user input. It's actually trying to stop your mouse input from passing through this control node, right? By right, it should already consume, or you can say it already blocks the mouse input. But the way we are detecting the input here, this input doesn't really care whether it has already been stopped or not. But we have another way of checking input, which cares. So it is another default function called unhandled input event. Right. This is similar to your ready function and the physics process function. They are default functions. Right. We can copy the original logic inside this function, and we can change it to if event dot is action press UI mouse click, then we shoot the arrow. Okay, so this function, from the name, it means that is only triggered when the input is unhandled, right? But the input is being blocked by your button, is being stopped or consumed by the control node. It's no longer an unhandled input, so this one will not be triggered. Okay, yeah, that's the logic. So here we can see that when we press the pause button, the arrow is no longer being shot. But for anywhere else that the mouse input is not being blocked, it's still unhandled, then it's going to go through this function, this unhandled input function, and then it checks if the event is mouse click. If it is, then shoot the arrow. Okay. All right. Yeah. Let's go back to the UI of the button and add some more beautiful UI to the button. Maybe there is a default cursor shape under the mouse, right? We can change it to some other cursor shape, maybe just a pointing hand. So it feels more like a button when you hover your mouse over it. All right. We can also change the font of this button in order to be consistent with the other fonts. So similarly, we go to theme and create a new theme and then drag our font inside. Drag our font inside and change the font size to 32 maybe. Okay, so now you see that this font is a bit strange because it's not being centered. Right. This one, okay, I'll just show you how do you solve this problem. Let's clear the theme first. We shouldn't clear the theme. We should have the same theme, and then we change the font to be new font variation. So this allows us to make some variations on the original font, right? So let's see what we can do here. New font variation. We need to click on the font variation first and then drag the font inside the base font. Okay, the size should be 32. But there are some variations that we can do to the font. For example, this extra spacing. So we just set, because we want the spacing at the top to be less, right? We just decrease the top spacing until it's until it looks good. It is being aligned at the center. Okay, so maybe we want the button to be slightly larger. No, I mean, I want to change the button size so that when it is resume, it can fit the resume, the 6 letters. Let me change the button size. Where's the button size? Oh yeah, here. Oh, sorry, it's in the layout and transform. So maybe I want to increase the size a bit, or not the Y size. The X size to be 65. Yeah. Okay, now we have this button. Okay, so now when you hover over the button, it should show a pointing hand, right? And it also has the correct font, and then it's big enough to contain the 6 letters of resume. Okay, so that's all the UI enhancements that I have made to the button. Okay, so this is the button to pause our game. And now let's talk about other buttons that allows us to select different levels. Okay, so you guys can imagine that we have 2 buttons here that when you press 1, it goes to the first level. When you press 2, it goes to the second level. Okay, before we create the buttons, let's try to understand the logic. Okay, so currently, our game structure doesn't look like this. We don't really have this level 1 node. Okay, so we only have a game, and then under the game, there is a map, player, and UI, right? So our goal is to add a level 1 node here, right? So this level 1 node represents the first level. And then imagine that there are different levels under the game node, right? Then we can switch between these different level nodes. That should be the desired structure of our game. And okay, so let me just mention that this entire thing is called the scene tree. You guys have heard me talk about this term many times, the scene tree, right? So this is just a tree structure of all the nodes that come from your scenes. Or this is the scene tree, right? And when you call get tree, it returns this entire tree itself, this tree object itself. And if it's get tree dot get root, it returns you this root node. All right. So that means you can get tree dot get root dot get node game. Then you can access the nodes from the top of the tree instead of the relative spacing, relative positions. All right. Yeah. Okay. So we were talking about the logic to handle the levels, right? So the logic should be in the game node itself, because it should be separate. It should be above the levels, right? It should be some node that's above all the levels, which it should be a script that attached to the game node, right? So how do we handle the levels? Okay, the overall idea is just to instantiate a new level, right? Add the level as a child of the game node. So you can imagine, let's say I want to go to level 2, right? I should instantiate level 2, add it to as a child of this game node. We have a level 2 node here, and then we get rid of the original level by calling Q3. So after that, it should be root game level 2, and your game should only have level 2. Okay, so actually here this order matters. We can't Q3 the original level before adding the new level. Why is that? Maybe I'll give you 5 seconds to think about it. Okay, so what happens if we Q3 the level first and then instantiate the new level and add? One shortcoming is that when you Q3, let's say it immediately immediately frees itself from the game, right? Then there will be a short period of time that your game screen is blank because there's no level. Assume that it takes a long time to instantiate a new level here, right? There will be a period of time that this is being freed, and then the new level is still loading, right? Which is not what we want. So the proper approach is to add the new level first, make sure the new level has been added, then you Q3 the first level, so that there wouldn't be a small gap of time that the user is facing a blank screen. Okay, yeah, make sure you have understood all this logic, and now let's implement the logic in our game. So we should first rearrange our game structure to look something like this. Now we have a game node, right? We should change the game scene into level 1 scene. It's not really the game, it's only a level, right? And we should also change the game script into level 1.gd, because in the future we'll have a game node and then a game script, the game.gd that's attached to that game node itself. So let's rename them, and maybe go to level 1 and rename this node as level 1 as well. Okay, so because we want to handle the level selection, let's just create a fake new level. Right? It should be a node actually instead of a node 2D, because the level itself also doesn't have a position. Right? So let's just rename the level 2 and then save it as level2.tscn. Let's copy some of the common nodes on the level 1 to level 2. So that includes the player. Okay, I cannot copy. If you cannot copy, just right click copy and then right click paste. So let's copy the player, the UI, right? As well as the parallax background. Okay, and rearrange them a bit. Or did I? So the background, UI, and the player. Okay, these are the common elements under these two games, under these two different levels. Okay, so remember that this is just a fake level 2 that we want to demonstrate our level selection, right? So feel free to add a new level when after this workshop and actually switch between the two levels. Okay, so now we have two levels. Let's add a new node, that is the game node. So the game node should also be a node, right? It doesn't need a 2D position, just a node. Let's rename it to game and save it as game.tscn. All right, we can add a script to the game to handle the logic we discussed just now. So we just add a script. All right, how do we implement the logic? It's also similar to your arrow, to the arrow, right? When you instantiate arrow, you need to preload the arrow scene first. And then whenever you need a new arrow, you instantiate the arrow from the preloaded scene, right? So we should do something similar, that we can define a constant, the constant levels first. Constant level 1, we just grab the scene via the preload function. Preload level 1.scene. And similarly, constant level 2 equals preload level 2.scene. Then we can store all the levels in a list of levels. Levels equals a list of level 1, level 2. Right? Okay. So we have a constant list of all the preloaded levels that we can access later. Okay, we will also need a variable on a current level that keeps track of the current level node, because we will need to queue-free the level node in the future, right? So let's keep it as a variable. And when the game is ready, we will set the current level to be level 1 dot instantiate. Right? We have created the level 1 and then assigned it to the current level. And then we just need to add the level into the game. So we add child current level. Okay, so that's the first level, right? Then we should define a new function that handles the level change. So let's define a function change level that takes in a number. All right. Okay, so under the change level function, let's have a variable new level equals levels, the n-1 index of the levels dot instantiate. This n-1 just means that this n can be 1 indexed. Right? Let's say you want to change to level 1, you just change level 1. And then because your list is 0 indexed, then it changes to levels, the 0th index of the levels, which is level 1. Okay. New level is levels instantiate. Then we should add the new level first. And after that, we queue free the original level. So the current level, queue free. And remember to set your current level to be your new level. So that now your current level is the new level. And in the future, when you want to change again, it knows that the new level is the current level. Okay, yeah, that's all for this change level function. And we can use this function in our UI. Let's create two new UI buttons that cause the change level function in the game. Okay, so inside the UI scene, maybe because we have defined all the properties to make this pause button look nice, let's just copy paste this pause button. Okay, let's rename the second button to level 1 button and the third button to level 2 button. Okay, for the level 1 button, let's move it to the right and then change the text to 1. The level 2 button, change the text to 2. Okay, and remember to reconnect the signals for these two buttons, because just now we duplicated the buttons. Then this signal is also being duplicated, which points to the same on button pressed function previously. But we don't want it to be this function, right? We want to disconnect the signals and then reconnect to the UI node, but this time with a different function name on level 1 button press. And we'll do the similar thing for the level 2 button on level 2 button press. Yeah, make sure that in your UI script, there are two buttons, there are two functions that is on level 1 button pressed and on level 2 button pressed, respectively. So now we need to define, we need to set the logic here that it should call the change level function in the game when these two functions are triggered. Yeah. So similarly, we will need to access the game node. So let's define variable game. And when the UI is ready, we should access the game node. Okay, so I mean you can do the same as previously. You can dot slash something and to get the game, right? But let me just show you another way of accessing the node from the top of the tree, which we discussed just now, right? Remember that we can get tree dot get node or get root. This gives you the root node, right? So in order to get the game, you just get node of the game, right? This is another way to access the game node. And then when the buttons are being pressed, you just call game.change level 1. And this one, game.change level 2. Okay, let's try. Oh, okay, something is wrong. Oh, okay. Oh, okay, never mind. Because we haven't really set the root node to be set this node to be game node. Okay, currently, remember last time we talked about if this level, if this scene is blue, right, then it means that this is the main scene, right? So the main thing is just the direct child of the root node. We will need to set the game scene as the main scene, right? Okay, so now the game is the main scene, and then it's going to instantiate the levels under itself. That way, when we run the project, this game scene will be played as the main scene. Then this will work. Okay, yeah, you should see a similar result that when you press 1, then it should restart in level 1. When you press 2, it should restart in level 2. Okay, right. Right. Of course, this UI is not ideal, right? This UI is stupid, right? So maybe in your actual game, you can have a button that pops up a new menu, which allows you to toggle between the levels. Or maybe in the game node, there can be another scene that's like the landing page. When the page that the user first and the player sees when they first enter the game, then there is some level selection, some options there. And in the game, when you quit to the landing screen, then the user can select the levels in the landing screen instead of inside the game itself. All right. Yeah. So that's all I want to talk about the level selection stuff. Okay. Let's move on to the last two topics, right? Okay, this one is the GitHub topic. So okay, if you are really if you are already using GitHub, like if you have a coding background and you are familiar with GitHub, maybe you can skip this section. But I'll just cover it briefly for those who are new to programming, because you will need to work as a team and you need GitHub to keep track of your group work. Okay, so what is GitHub? Right. In short, GitHub is just a version control software. Right. Actually, the version control software is Git. Right. The Git works locally. Like in your local computer, you can configure a folder to be a Git repository. Then there will be a file, a Git file that keeps track of the history inside this folder. And GitHub is just making it online, right? Different people can share the same history of their Git repository and then do some operations in their common repository. This is very useful for version control because yeah, people need to work at the same folder at the same time, right? Then you will need to update others when you have done when you have done your part of the code, and others need to update their repository when you are done, right? And then they can receive your update and they can push updates to you so that everyone is at the same page of the same repository. Okay, so let's go to github.com. Right? So register an account if you haven't, then go to profile, go to repository. Okay, so under your repositories, there should be a new repository. And maybe only when you do a team project, right? Only one team member needs to create a new repository and then share it with others. So I'll just demonstrate creating a new Godot repository, and you need to set the repo name, maybe my first Godot. Okay, so this is going to create a new repository with this name, my first Godot game. Right, can add an optional description here and configure the visibility settings. So if it's public, means that it's open source. It's open to everyone on the internet. If they do a Google search and find your GitHub repository, then they can view all your code. Okay, for today, maybe we can set it to private first. Okay, if you want your interviewer or your friends to see your repo, you should make it public. That also means they are free to access your code. Okay, so let's make it private first and add a README file. Okay, so this one, add a .gitignore template. Let's choose Godot. That's actually a Godot template. Okay, the license, we don't care. And then let's create a repository. Right, so there are two stuff that may be new to you. One is the README. So the README is a markdown file. The markdown file is a format of a text file that the content of this markdown file will be displayed at your repo page, right? So let's say this is my repo page, right? And when others visit this page, if the page has a readme.md, then this readme is going to be displayed here. If you go to this readme, this is the readme just contains this title for now, right? And when others view this page, then they will be able to see this readme file being displayed nicely here. Okay, and the gitignore file, go to the repo. So these are file name formats, right? So this means everything under the .godot folder. This means the file export.cfg itself. This means anything pre-trailing anything, and then end with .translation. Okay, so these file names are specified by the gitignore template that all these files shouldn't be tracked by Git. If you make updates to these files, Git shouldn't update their history in a Git file. So no one in your team will upload these files onto this GitHub repo. Right? This is important if your game has some unnecessary files that doesn't need to be shared. Let's say you have some cache files under the .godot folder, right? And there's no point of sharing the cache across the team. But if you share it, maybe every time you see thousands of files, thousands of cache files being uploaded, which makes the experience less desirable. That's why we should specify the gitignore so that we don't share the unnecessary files. Okay, so after creating this repo, you can invite all your team members. It should be under settings and collaborators. Oh, okay. I don't want to take out my phone to enter the code, but you should, after entering the collaborators, you should see a page that you can enter the emails of your teammates, right? And then just invite them, and they should receive an email to join this repository. Okay, so now let's cover how GitHub works. Right? So when your teammates get invited to your repo, everyone in your team should clone the repository. Okay, let me just. Okay. Oh, this is a GitHub desktop that I recommend you to use this software as a beginner, right? So Let's add. Let's go to file. Not file. Let's click on the current repository and then add to clone a repository. So you can just search for your repository here, or you can just enter the URL. This, if you go to the repo, then it should be this. This is the URL for the repo, and then you enter it in your GitHub desktop, so that it's going to access this. It's going to visit this GitHub URL and then download all its content to your local path. I think I already have my first Godot game here. Okay, let's for me, I just add my first Godot game too. Okay, now I'm cloning this repo and downloading all the contents. So after cloning a repo, it creates a local repo that is aware of the presence of this remote repo. Okay, so on your local computer, there's a local repo, and in the cloud, there is a remote repo. You can do stuff to the remote repo by pushing your changes and fetching and pulling the updates in the remote repo. Okay, so how do we make changes to the local repo and remote repo? It's via this thing called commits. So let's say I go to the repo that I cloned just now. Projects. Okay. Okay, and let's say I'm the team leader and I should init the Godot repo. Let's just go to Godot. Because currently it is an empty repo, right? It doesn't have all the Godot stuff. So let's open a new Godot engine. And then we will just add a new game project inside the repo that we have cloned. So it should be the edisk projects, this one. Okay. We can just select the repo that we defined just now, and then great. It should be fine because it doesn't contain any irrelevant files. So we can create in a non-empty folder for now. Okay, so I've created a Godot project inside this file, inside this folder, right? And now if you go to GitHub desktop, you will see these changes to your files. Because you are making changes locally, then Git is aware that you have modified all these files that is being tracked by Git. Okay, let's check. So the green lines means that you are adding these lines to the file. And then the red lines means that you're removing them. Okay, so we can see that the new Godot project is actually removing some lines from our git ignore. And if we don't want it to remove, we can right click on this change and then discard changes. Confirm discard the change to this particular file, right? Then it's going to undo the change, right? It's going to revert it back to the previous version before we created the Godot project. Okay, so yeah, make sure to review all the changes that you want to apply to your folder. And you can tick or untick to choose which ones you want to include in the current change, right? And after you have confirmed this, you need to commit. You need to make a commit to the repo. Okay, let's create some commit message. Let's say init repo, init Godot project. This one is the message associated with your commit. And then to commit, it means you apply the changes to your local repo. Let's click commit. Okay. Now if you put history, then this shows that you have committed your changes to your local. Right. This will commit this. So there will be a new commit to your local repo, right? But it is only in your local. And in order to update this commit to the remote, you will need to do this push operation, right? So you can see there's an indicator that this commit hasn't been pushed to the remote repo. So we just push here. Okay. Now the push just means you are updating the remote with the new commits in your local repo, right? You upload the new commits to the remote. All right. Okay. How about let's say your teammate has pushed their commit to the remote repo, this red one, and you want to get their new commit. You want to update your current local repo with the new commit. Then you need to use these fetch and pull commands. So fetch just means you are checking the updates in the remote, and then you download those updates, and then you pull to apply these updates to your local repo. Okay, now it's a bit hard for me to demonstrate, but you can imagine that, okay, your teammate tells you, oh, I have added a player to the game, right? Then you want to download the content from the teammate, then you just press this fetch origin, right? Then if there's an update, then it should show pull changes from the remote. Then you just pull it. It should show here, show in the history of your local repo. Yeah, so that's pushing and pulling. It's quite intuitive, right? Okay, but here comes a catch. So the most undesirable thing in the GitHub development is something we call merge conflicts. Okay, let's imagine this scenario, right? So in the red commit, the player speed is 200. Your friend changes the value from 200 to 300, and you change the value from 200 to 400. Both of you have committed this change locally, right? And then before you pushed, your friend pushed this 300 onto the remote, and now you are trying to pull from the remote repo. Okay, what happens? So there will be two different commits. The commits are basically changes to the files, right? So this commit is trying to change it from 200 to 400. And this commit is trying to change from 200 to 300. And Git is unsure which value you want to keep at the end. Right? This is what we call merge conflicts. And you will have to resolve the merge conflicts before continuing. You need to tell Git, oh, my final value should be 400 or 300 or 355, take the middle, and before doing other operations. Right? So moral of the story is try not to edit the same file. One person should, even if you are editing the same file, try not to change the same value. Right? So only one person should be responsible. Ideally, should be one person responsible for a file. But if you have to share one file, right? Make sure you think it through. Maybe one person is in charge of the player's properties, like the speed, the health, etc. Another one takes care of all the functions that the player has. Right? Try not to edit the same section of the same file. Okay, so now let's move on to the branches of GitHub. Let's go to GitHub desktop, and then in the current branch, you can see the current branch is main, right? Let's create a new branch. I will call it家乐 workspace. Yeah, you can name it whatever you want. Your name workspace, your name slash player, something, right? Just create this new branch. So you have created a new branch locally, and then you need to publish it to the remote. Publish this branch. And why do we need to separate the code into different branches? Okay, so rule of the thumb is to always work in your own branch. Right? Make sure the main branch is the single source of truth for everyone. Right? And then after working in your current branch, you don't merge to the main branch directly because there may be merge conflicts that have undesirable effects. So you should merge from the main to your current branch, your current workspace, and resolve all the merge conflicts if there is any after you have resolved all the conflicts, then you merge from your branch to the main branch. Okay, that may sound a bit confusing, so I have an illustration for you. Okay, let's first talk about the process of merging from one branch to another branch. Let's say I have a new commit in main. Right? This commit is in the remote, and you are working in the new branch that you have created. In order to merge from the main branch to the new branch, you need to first switch to the main branch. Pull the commit from the remote to your repo to your local repo, right? Make sure that your local main branch has this commit, and then you switch to your new branch, and then merge from the main branch. There should be an option in GitHub desktop that's called update from main. I'll show you later. Yeah. So this merging operation will just apply the new commits in the main branch to your new branch. After that, you can commit this commit will be called the merge commit, and then you commit the merge commit and then push it to the remote new branch. Okay. Don't know why there's a publish. I shouldn't publish. Okay, never mind. Okay. I will demonstrate the merging operation. So let's say in the main branch, okay, I'm your teammate, and I have just updated the README file. I've added contributors. Okay, now my name is Yalo. Okay. So doesn't matter. So I will commit and push to the main branch. Okay, recall that this is your teammates' work. Your teammates have uploaded it to main, right? And then on your side, you're working on this branch, right? You should go to main branch, fetch to pull from the remote. Make sure your local main branch is being updated. Then switch back to your own branch. Then under the branch, update from main. right? This update from main is just a shortcut. It's the same as merge into current branch and you choose main. So this will merge this one new commit from main to your workspace. Okay. Now, if you check the history, it has merged the new commit from main to your Jala workspace branch, and then you can push it to the remote. All right. Yeah, that's the process of merging between branches. And let's consider the unfortunate scenario of merge conflicts. How should we handle this? Okay, I think I can show you later. I can show you I can demo later. I'll show the illustration first. So let's say your evil friend have changed it from 200 to 300, and then you're also doing some changes in your new branch, right? The typical workflow will be you switch to it will be the same as just now, right? You should switch to your main branch. You should pull all the updates from your teammates. You should get the 300 here. And then you merge from the main to your new local branch. There will be a merge conflict in your new branch. It's trying to set to 400 and 300 at the same time, right? And you should do something to resolve the merge conflicts here. You should set it to something that resolves this conflict. I denote it as the golden block, right? This is the merge conflict. This is the merge commit that resolves the conflict. So you should commit this one, and you push the merge conflict. You push the merge commit. Then you switch to the main branch, merge from your branch. Okay, right? And commit and push to the remote main branch. Now you can see that every branch is being updated with the resolved commit. There will be no more conflicts. So in short, what we do, you switch to main branch and you update all your teammates' work, and then update your own branch with their code. If there's any conflicts, you need to resolve the conflicts, right? And then you merge from your branch to the main branch to update others of your progress. Yeah, that's it. It may sound intimidating, but once you get used to it, it's quite intuitive. Well, let me just do a demo here, right? So let's say I am myself, and I think this should be contributors, right? Contributors, right? So I have changed from contributors to contributor Z, and I have committed this update to Z, committed this change to my branch, right? Push this, but I haven't updated the main branch with this commit. And now I'm my teammate. My teammate wants to change the contributors to contributor SS for some reason, okay? And then my teammate has add S into have made this commit to main, and he has pushed it to the main branch. So let's say yeah, I'm working here, and now I want to update this commit to the main, right? And before that, I should update it from main. I should go to main, pull all the updates in the main, and then go back and update from main to make sure that my branch is up to date with my teammates' progress. Right? Then it was say that there is one conflicted file because of the scenario of two people editing the same line, editing the same property. Okay, so you can choose to open in some editor. some code editor, right? Then it should tell you that what's the conflict. So what's the current change and what's the incoming change? Current change is your own change. You're changing it to contributor Z, and the incoming change from the merge operation, the incoming change from the main branch, right, is changing it to SS. So you can choose to accept your change, accept the incoming change, right, or accept both changes, and then you manually change it to contributor ZZ for some reason, right? Okay. Now, after you have resolved this one, there should be no more conflicts, and you can continue the merging, right? Then you can push the new change in your local repo, in your local branch, and then switch to the main and update the main with your local branch, with your own branch. So in the main, you can merge into current branch and choose your own branch, then create a merge commit. So now the main branch will also contain ZZ. Yeah, it is the result from your branch. Okay, I hope this is clear. Yeah, if you are still a bit unsure, just make sure to follow this workflow when you're working in a team. Okay, so that's all for the GitHub portion. Now let's talk about how do you export your game project and publish it to itch.io. So let's go to our Godot. Let's go this one first. Okay, so after your team has confirmed you are done with the game, right? Go to project, export. Right. Now you can add a preset. Let's choose the web preset because we want our game to be playable in the browser. We have a web preset. And okay, some of you may see a warning here that there is no project template or preset template or something, right? There's no template, and there is a manage project templates hyperlink. So you can go to that hyperlink, and then there should be some place for you to install a preset, right? After installing the preset, after it's done installing, right? Just go to the project export again. Let's go to this same page again. So yeah, if you need to download, just pause the video and then resume after it's done. Okay, so now everyone should have the presets already. And yeah, there's nothing much we need to configure for now, right? Yeah, and there are two options. One is to export the project. One is to export the PCK. Well, basically the PCK contains a compressed version of your game assets and game logic. And the project is an entire folder with the PCK and other stuff and other files that is required for your game to be runnable as a web app. So for our purpose, we need to export the entire project with all the relevant files. Let's click on the export project. And I strongly advise you to create a new folder. Let's call it output. Why? Because Godot will not create a new folder for you. So it's going to create all the different files scattered in this folder. Like it's not a new folder, but there'll be separate individual files being added to this folder. So we should arrange them in a new folder. Let's call it output. And then for the file name, let's name it as index.html. Right. This is because later each IO will ask you to rename the file to be index.html, because in the case that there are multiple HTML files, each IO needs to know which one it should refer to. Right? So why not we just change it to index.html now? Okay, so let's save the project. And in the project folder, there should be a new folder called output, right, with all the files being generated, including the PCK and all the other relevant files. Okay, now what we do is we should zip the entire output folder into a zip file. Yeah, we should get this output.zip. And this zip file is what we upload to our itch.io. Okay, so let's go to itch.io. In your profile, there's a dashboard tab. Let's go to the dashboard tab. And there's a button to create a new project. Okay. So let's give our project a title first. Let's call it my first Godot game. Yeah, it should give you a project URL. You don't have to change it. You can change it if you want, but you don't have to, right? Then let's change the kind of project into HTML. So it's not going to be a downloadable game, but it's played in the browser. Right? Then we can upload the file from my first Godot game. Yeah, this output.zip. You see, there must be an index.html file in the zip. Okay, we have output.zip, and we should check this option that the file is played in the browser, so that each IO will know that this zip file is intended to be played in the browser. Okay, yeah, okay, that's enough for you to upload the game. And there are some other properties that you can configure. Let's say the cover image, that others will see your cover image before they click on your game. So let's choose a random cover image. Let's say we just choose a night image. And this is our cover image. Okay, so there are some classifications of this project. It can be games, assets, etc. You can set the viewport size, right? So this one you can get from project settings. There is a window property which displays the sizes of your viewport. So 1152648. Let's set it to be 1152 times 648. Okay, and then there are some other options, and this one is important. Okay, this one, shared array buffer support. Make sure to check this one. So this is actually an issue with Godot, since Godot 4, that it requires this shared array buffer support. Otherwise, your game cannot be run. I think they have fixed it in Godot 4.3, but unfortunately, our version is 4.2.2. So we will need to check this one. Okay, feel free to provide a description to specify the genre of your game, etc. Right now, there's a community, so you can specify if others can comment under your game. And then the visibility status. Right? For now, maybe we can set it to be restricted, so only yourself and people you know can view this page. Right? for an actual game project like your game jam or your level 1 games, you can make them public so that strangers can also go to your game page and play it. Right, let's save our game and try to run it in our browser. Right, it should be similar to our playing experience in the Godot editor. Right. Yeah. Check that all the buttons work. Right. Yeah, that's it. So congratulations to everyone for making and uploading your first game. Right. I hope you had fun in this process. Okay, let's close this one. Right, that should be it. Yeah, so this is the end of this entire workshop series that lasted 4 weeks. So we have started from very basic skills to eventually making bigger games, being able to start a game project and work on it as a group, then eventually publishing it to be viewed by the public. Right? So what happens next week is we will have this event called Level 1 Games. So Level 1 Games is basically game projects for starters like us. So we will form groups among us and form groups among all the Godot developers and start to ideate for a game project and finish the game project by the end of this semester before we finally play test and show it to everyone. Yeah. So if you are watching this online, please come to the physical venue next week, right? There is not going to be any more online workshops. It's going to be purely physical events, right? So please join us. Please come and share the fun together of making games, meeting new people, making games, starting on real game projects, and apply all the skills that we have learned in the past 4 weeks. Okay, so one last thing I want to talk about is week 5 game jam, which happens in this Saturday, the Saturday of week 5. So this is a game jam event that we form groups on the day itself and then try to, it's kind of like a hackathon style, but you make a game within a short duration from 12 p.m. to 10 p.m. on this Saturday. And there will be lots of free snacks and pizza for everyone. And a reminder for you all is you need to bring a stationery to this game jam for some unknown purpose. So maybe my hint is that in order to stand out from other teams, right, bring some stationery that is wacky, that is very uncommon, so that you have more areas that you can think about when you design your game. That's my tip for all of you. Okay, right. So that's the end of today's workshop, and I hope you have enjoyed these 4 weeks and looking forward to any games, any projects that you are going to start off and doing in the future. Yeah. So yeah, that's it. Thank you, everyone.